A student have called me and he said that I have been watching all your videos on differential equations and I still cannot solve this problem. For this problem, I am going to show you how to solve differential equation in series. You can use this method in solving all sorts of equations like this. In series, we can write a general solution for the differential equation like this as y is equal to a0 plus a1x plus a2x squared plus a3x cubed and so on. Usually the problem might ask us to what order we should get the answer to. So what we have to do, if we assume that as the general solution, so in order for us to solve this, we have to find the values for the coefficients a0, a1, a2, a3, and plug it in this formula. Then we can get the solution to that differential equation. So in solving differential equation in series, we can assume the first step, we can assume that our solution is summation of n from 0 to infinity of a n x to power n. So we can assume that this is the solution, and then we can take the first derivative and second derivative of this solution and plug it in this equation, and then after that, the second step, we can rewrite the summation in the form of Bn x to power n. And what does that mean? Once we get the first derivative, we are going to have x to power n minus 1, and then the second derivative, we are going to have x to power n minus 2. So we don't want our exponent to be in this form. We want our exponent just to be like this. So this is the next step, and then after that, for different values of n, we can start at n0, 1, 2, and so on. For different values of n, we will be able to find these coefficients. And once we find those coefficients, we can plug it in this general solution like this and find the solution for that differential equation. So let's go ahead and solve this differential equation using the series method. So we said we have to assume that y is summation of n0 to infinity. So here our dy dx will be equal to summation n from 1 to infinity of, and the differentiation, if we differentiate that, we are going to have n an x to power n minus 1. And our second derivative, d2y dx2 will be equal to summation of n from 2 to infinity of n multiplied by n minus 1 an x to power n minus 2. So this is our second derivative. Now we have the values for the second derivative, the first derivative, and for y, now we can plug that in this equation. So if we plug that in this equation, the first portion will be summation from n equal to 2 to infinity of n times n minus 1 a n x to power n minus 2, then plus x multiplied by this. So if we multiply x by this part, so this exponential will be x to power n minus 1 plus 1. Minus 1 plus 1 will be 0, so we are going to have x to power n. So this will be plus summation of n from 1 to infinity of n a n x to power n. Because we multiply this x by that x to power n minus 1, x multiplied by x to power n minus 1 is equal to x to power n minus 1 plus 1. Minus 1 and plus 1 will cancel, so we're going to have x to power n. Plus, now here we got two portions. First portion, 3x multiplied by y. This is our value for the y. 3x multiplied by y, we are going to have x multiplied by x will be x to power n plus 1, so 3x, so we are going to have summation from n equal to 0 to infinity of 3 a n x to power x multiplied by x to power n is x to power n plus 1. And then the last portion, 2 multiplied by y. 2 multiplied by y. So that we can write that as plus summation n from 0 to infinity of 2 multiplied by y, which will be 2 a n x to power n equal to 0. You have to be very careful. It's very easy to make mistakes in problems like this. So I hope I don't make a mistake. So now this is where we are. Now the next step, we say that we don't want our power be like that. We want to write all the summations in a form of bm x to power n, not n minus 2, not n plus 1, all x to power n. So how we do that? Let's go ahead. On the first summation, our power is n minus 2, and we want to write it in a form of bm x to power n. So that means in the first summation, let's say that n is equal to n minus 2. So if n is n minus 2, this will be in the form of n rather than n minus 2. So we can write this summation as n is n minus 2, so n will be n, which is 2, minus 2, so n will be 0, from 0 to infinity of n. If n is n minus 2, therefore n is equal to n plus 2. So here n, instead of n, we have n plus 2. and n is n plus 2 minus 1. Plus 2 minus 1 is plus 1, n plus 1, and a, and this a, n is n plus 2 multiplied by x to power n. Now let's do on the second summation. Already we have n, so we can on the second summation n is equal to n. So this will be plus m from 1 to infinity of n a n x to power n. Now on third one, we want to get rid of this n plus 1. So we assume this and we want to write it in this form, x to power n. So our n is n plus 1, or m is equal to n plus 1 so this is plus summation. Our m will be is 0 here, so our m will be from 1 to infinity multiplied by 3 a n. If m is equal to that, so n is equal to n minus 1. So this will be a of m minus 1 times x to power n. Now the last part, again, we have n to power, so we can have n equal to n, so we can just write that as n from 0 to infinity of 2am x to power n equal to 0. Now we have done that step. We wrote this equation. In the form of bn x to power n, and that is that right here. Now the next step is for different values of n, we can find the coefficients. This a1, a2, a3, and so on. So let's go ahead and start with m0. So if m will be equal to 0, we can see this in this equation. Only two summations are from n can be 0. One is this summation that goes from 0 to infinity, and the other one is the last summation from 0 to infinity. So if we only on those two summations, n can be 0. So for m0, we are going to have here, if we plug 0, we are going to have 0 plus 2 times 0 plus 1 a2 plus, and for this, for m to be 0, we are going to have 2a0 equal to 0. So here we are going to have 2 multiplied by 1 is 2, so we are going to have 2a2 plus 2a0 is equal to 0. So from here, if we divide both sides of the equation by 2, these 2's will cancel out. So we can see that our A2 is equal to minus A0. So here we already found the value for A2. Our A2 is minus A0. Now let's go ahead and find. Let's go ahead and for m equal to 1. We know that for m equal to 1, that applies to all the summations. So on this one, for m equal to 1, we are going to have 1 plus 2, which is 3, multiplied by 1 plus 1, which is 2, multiplied by a is equal to 1, multiplied by A3, plus m equal to 1 plus 1 multiplied by A1 plus m is 1, so plus 3 multiplied by A0, 1 minus 1 is 0, plus 2 plus 2A1 equal to 0. 1, 2, 3, 4, 3, 2, A3, and this one is 1 times A1 plus 3A0 plus 2A1. You have to be careful. So from here, we have A1 here and plus 2A1, so we can have that plus 3A1 equal to 0. So here 3 times 2 is 6, 6A3 plus 3A0 plus 3A1. So let's go ahead and divide both sides of this equation by 6. So this 6 will cancel out. This we are going to have 1 divided by 2, and we are going to have again 1 divided by 2. So A3 will be equal to minus A0 divided by 2 minus A1 divided by 2. So we also found the value for A3. Now let's go ahead let's go ahead now assume that m is equal to 2. M is equal to 2. For that, we are going to have, if m is 2, 2 plus 2 will be 4, multiplied by 2 plus 1 is 3. This is A is 2, so this will be A4 plus m is 2, so that will be plus 2 A2 plus 2A2 plus 3A, m is 2, so 2 minus 1 is 1, plus 2, A is 2, A2 equal to 0. So here 4 times 3 is 12, 12A4, and we got, we can write this as 12A4 plus 4A2 plus 3A1 is equal to 0. So here we can write as A4 will be equal to minus 4A2 divided by 12 minus 3A1 divided by 12. So here A4 will be equal to minus A2 divided by 3 minus A1 divided by 4. So this is the value of A4. And we already have the value for A2, which is minus A0. So here, if we put minus A0, minus times minus will be positive. So this will be equal to A0 divided by 3 minus A1 divided by 4. So this is the value of A4. Now we have fun. Now we have a A0, A1, A2, A3, and A4. We can plug it in this equation and have the solution for this differential equation. So let's write that down. So y is equal to A0 plus A1x plus A2x squared. Our A2 is that, so is minus A0, so will be minus A2x A0x squared. So that was our A2 plus A3x cubed. A3 is that. So A3x cubed. So if we multiply that by x cubed, we are going to have minus A0 divided by 2x cubed minus A1 divided by 2x cubed. So this is for this portion. And the next part is A4 multiplied by x to power 4, and so on. So now our A4 is that. So we can write this A4 times x to power 4. So this will be plus A0 divided by 3 x to power 4 minus A1 divided by 4 x to power 4. And so on. Usually in a problem they would let you know that to what order they want you to go ahead. So this is the general solution using the series method in solving a differential equation like this. And this was an excellent question, because now I feel my videos are complete. Almost a few more differential equations, but it will be complete. So by using this method, you can solve any differential equations. I hope you like it. Thanks.